Okay, in this video, we are going to learn about the data manipulation with Pandas Part 2. First, we are going to learn about the hierarchical indexing. We start from the multiple index series. Let's start by considering how we might represent two-dimensional data with a one-dimensional series. For concreteness, we will consider a series of data where each point has character and numerical key. And suppose you would like to track data about states from two different years, yeah. So for example, we have a data that represent the population of the states of each year, and we have two different years. So yeah, we will discuss about how to track the data about states, yeah, from two different years. And when using the pandas tools we've already covered, you might be tempted to simply use Python tuples as keys. So here the example of the multiple index series. We have the index, yeah. So this is an array. This is an array, and we have California in 2000 in years in 2000 and California in years in 2010. And we also have another state here, New York and Texas. Each of these states has 2 years, two different years, 2020, 2010. And we also have the population. So the population around, yeah, let's say this is the 3 millions, yeah, 3 million somethings for the California in 2000 and 3.7 millions in California in 2010, yeah. So it means the population represents the population of each state on years 2000 and 2010. So if we see here in the right side, you see the multiple index, right? Multiple index, which is we have California as the states, and we also have the years. California in 2000 we have this population, and California in 2010, yeah, we have also another population here, and so on and so on. So here we have a multiple index. Yeah. So how to handle the multiple index series? So for example, here we create a new variable and we call it as a pop, yeah. Pop equal p.series populations. So it means we convert the populations variable to a pandas series, and we set the index for this population from the index variable. So it means we have the index here. Index represents two data, the states and also the years. And if we print the pop variable, you will see the output like this. So yeah, let me open my Google Colab. So here we create index variables and populations. So we have multiple index, right? In the index variable, we have two different data, the states and also the years. And if we print the pop, yeah, the pop is represent the population of the states of each year. So you will see the output like this. Okay, so we have multiple index, right? So for example, yeah, if we need to select all values from 2010 or 2010, yeah, you will need to do some messy and potentially slow marking to make it happen. So it means if we have multiple index, then we use a regular indexing in a NumPy array. So or regular indexing in pandas series. So we need a code like this: print pop I for I in pop.index if I index 1 equal 2010. Yeah, it's yeah, we can see that this is the some messy and potentially slow code, yeah, for getting the data on 2010 years. So actually, yeah, it will give you the right output, but yeah, it require more time to execute this code. And this is a bad way to getting the data from the year 2010. Yeah, and this produce the desired result, but it's not as clean or as efficient for large data set as the slicing. So we have another method to handle this multiple index series. And fortunately, Pandas provides a better way. Our tuple-based indexing is essentially rudimentary multi-index, and the Pandas multi-index type gives us the type of the operation we wish to have. And we can create a multi-index from the tuples as follows. So we need to uh, change the index variable to a multi-index using Pandas multi-index. So it means we have method here, right? We have method pd.multi-index from tuples, and we give the parameter to index, right? So we convert the index array, yeah, to a multi-index Pandas series. And if we print the index, it will give you the output like this. Okay. For example, here, let's take this code and also this one. We convert the index array to a multi-index Pandas series. So it will give you some of the output like this. Yeah, this one is the multi-index, and on each index we have two data, the states and also the years. After we convert the index variable, so if we do the reindex, yeah, so if we reindex our series with this multi-index, we see the hierarchical representation of the data. So after we convert the index array to the Panda multi-index, and we print, we create, yeah, we print the pop variable, yeah, we print the pop variable, and pop equal pop dot reindex, and we give the parameter to index. And if we print this one, okay, it will give you the output like this. So we have states and also we have the years, but actually we don't print the California, New York, and Texas two times, only one time, right? So because of we already convert the index, we already convert the index array to the multi-index Pandas. So it will give you output like this. Each state has two different years, 2020 and 10. And it will give you also the population of each year. Yeah, here the first two columns of the series representation show the multiple index values, while the third column shows the data of the population, right? So this one is the third column represent the population. And you need to notice that some entries are missing in the first column. Yeah, in this multi-index representation, any blank entry indicates the same value as the line above, because we have two California, we have also two New York, so we don't need to print it two times. Okay. Now to access all data for which the second index is 2010, we can simply use the Pandas slicing notation. So for example, this is the code for representing only the population of each state on 2010. So we only need to print the pop and colon, comma, 2010. So it will give you only the population on years 20 and 10, 2010, right? Okay, so if we print this, if we execute this code, wait, let me execute this code first. Then it will give you the data that represent the population of the California, New York, and Texas only on years 2010. And the result is a singly indexed array with just the keys we're interested in. And the syntax is a much more convenient, and the operation is much more efficient if we compare with our previous code, right? And yeah, the operation is much more efficient than the homespan tuple-based multi-indexing solution that we started with. So that's all from the multiple index series and how we convert the index NumPy, yeah, to the multi-index Pandas, and this is the way to represent also the data using the multi-index Pandas series. Okay, and the next one is we could easily have stored the same data using a simple data frame with index and column labels. In fact, Pandas is built with this equivalence in mind. The unstack method will quickly convert a multiply index series into a conventionally indexed data frame. So for example, this one. So we can also convert our multiple index data to a data frame because as you can see here, actually this one is also can be represented as a data frame pandas, right? So how to convert our multiple index into a data frame, pandas data frame? So we can just use the unstack method like this. Okay, we create a pop underscore tf variable equal pop.unstack. So this one is the method to convert the multiple index data series to a data frame data. So it will give you the output like this. Yeah, it's like a table. We have the columns and also we have the rows, and each cell on this table will represent the population, right? So we can use the unstack method. And the next one, if we want to uh, convert it back to a multiple index series, so we can use the stack method, right? So let me execute this code. It will give you the output like our previous code, right? So actually this one, yeah, we can also represent it as a data frame using the unstack method. And the next one, yeah, seeing this, you might wonder why we would further with hierarchical indexing at all, yeah. The reason is simple, just as we were able to use multi-indexing to represent two-dimensional data with a one-dimensional series. We can also use it to represent a data of a three or more dimension in a series or data frames. Actually, uh, without the multiple index series, we can represent data using a data frame. But actually, yeah, we can also use a multiple index to represent more than one-dimensional data to a one-dimensional series. Yeah, each extra level in a multi-index represent an extra dimension of data. Taking advantage of this property gives us much more flexibility in the types of data we can represent. And with a multi-index, this is as easy as adding another column to a data frame. Okay, the next one is explicit multi-index constructor. So let me minimize this text cell. Okay, the next one is explicit multi-index constructor. For more flexibility in how the index is constructed, you can instead use the class method constructors available in the pt.multi-index. For example, as we did before, you can construct the multi-index from a simple list of arrays giving the index values within each level. So let's see this code. Yeah, we have three different code here. We have a pt multi-index dot from arrays and from tuples and also from products. So all of this code will represent the same output. Okay, let me show the code first. Oh no, wait. Okay, let me find the code first. Okay, so this one is the example of the explicit multi-index constructor. So actually we can construct a multi-index uh, variable. So this one is the example how to create the multi-index variable. We can use the pt.multiindex.from arrays, yeah. So the parameter inside the method will be the arrays, yeah, two different arrays or some of the different tuples and also uh, two different arrays, right? So if we use the from arrays, so it means it will give you four, yeah, four different index a comma 1, a comma 2, b comma 1, and b comma 2. And you can also create the multi-index from tuples. So we need four tuples here. Yeah, A equal A, comma 1, A, comma 2, B, comma 1, B, comma 2. And you can also construct the multi-index using a Cartesian product. So we only require two different arrays here, A and B and 1 and 2. So it will give you the same output with our previous code with using tuples or array. So it will give you A, comma 1, A, comma 2, B, comma 1, and B, comma 2. Okay, let me use the last code, yeah, because this one is more simple if we compare with the previous code. So it will give you the same output with tuples and array. Okay, so yeah, sometimes it is convenient to name the levels of the multi-index. Yeah, we can accomplish this by passing the names argument to any of the above multi-index constructor or by setting the names attribute of the index after the fact. So we can also give the name of our index, right? So for example, this is the code to give the name for our index, because we have two different index here. We have a state and also the year. So we can use this code pop.index names, yeah, equals state and year. So the state, it will represent the first index and the year will represent the second index. If we print the pop variable, it will give you the same output with our previous code, but actually this one also give you the name of the index for the first index and also the second index. Okay, let me execute this code first. Then this one, it will give you the name of your index. We have state and also we have year. Okay, the next one is the multi-index for columns. What we have discussed before, we only give the multi-index for our rows, not the columns. Actually, we can also give a multi-index values to our columns in our data frame. So yeah, in a data frame, the rows and columns are completely symmetric, and just as the rows can have multiple levels of indices, the columns can have also multiple levels as well. And consider the following, which is a mock-up of some medical data. So yeah, let's just represent some of the data frame. Yeah, here we can have two different variable, yeah, index and columns. Yeah, so index, we have two different index here. Yeah, for the index variable, we have year and also we have 1 and 2. 1 and 2, it represent the visit. Yeah, this one is the year and this one is the visit. And for the multi-index for our columns, we also have subject. Yeah, the patient. Yeah, it can be the patient, or we can call it as a subject, and HR and temperature. HR, it means, yeah, this one is temperature. HR is for the heart rate, right? So let's just imagine we have a patient, and the patient visited the doctor, and the doctor will calculate the heart rate and also the temperature, the body temperature, and each of these patients has visited the doctor 2 times, right? 2 times in year 2013, they visit the doctor 2 times, and also in 2014 they also visited the doctor 2 times. So we have multiple index for the rows and also multiple index for the columns, and we can just mocking some data. Yeah, we can just randomize the data using this code. Data equal np.round, np.random.rank n. So because we have a 4 times 6 data, right? Because if we represent the data using a data frame, we will have 4 rows and 6 columns, right? 4 rows because we have 2 years, yeah, and also 2 visits, right? So it will give you the 4 rows, and we have 3 patients, and each patient will be calculated for their heart rate and also their temperature. So we can have 6 different columns. So this code is just for randomizing the values, yeah, using uh, Gaussian distribution or normal distribution. For comma 6, it will represent the size of the data, and 1, the parameter 1 will represent the uh, standard deviation. So you can just playing around with this variable, these parameters, yeah. So we can just follow the code in the slide. So this one is the standard deviation for our data variable. Okay, let me execute the code first, yeah. So this one is for randomizing the data using the Gaussian distribution. So it will give you this data. Then after that, we multiplying of these items, yeah, with 10 values, right? So uh, all of the item in our data variable will be multiplied by 10 only for the rows 0, rows 1, rows 3, yeah, because we have two steps here, right? Two steps. So all of the data in column 0, uh, column 2, and column 4 will be multiplied by 10, right? So if you print the data, it will give you the output like this. Then after that, all of the item in our data variable will be added by 37 values, right? Data plus equal 37. So all of the item in our data will be added by 37. Then after that, we convert the data variable to a data frame. So we create another variable here, help underscore data equal pd dot data frame. And because we want to convert the data to a data frame, so we need a first parameter. We give the first parameter as a data. So the index, yeah, equal index, and the columns equals columns. So we already create the index and columns before, right? This one is the index, yeah, the index for the rows. We have two index for the rows and two index for the columns. So we give the parameters index equal index and columns equal columns. And if you print the help underscore data, it will give you the output like this. So we have two different index in the rows, and also we have two different index in the columns, right? Okay, we see where the multi-indexing for rows and columns can come in very handy. This is fundamentally for dimensional data, where the dimension are the subject, the measurement type, the year, and the visit number. So actually, we can represent four-dimensional data to a two-dimensional data, right? Because we have a two different index for the rows and also two different index for the columns. So yeah, we can say that we have a four-dimensional data that we can represent it as a two-dimensional data. And with this in place, we can, for example, the index the top level columns by the person names and get a full data frame containing just that person's information. So if we want to get the data for one patient, yeah. So for example, we want to know the data from the Q2, yeah, Q2, because we have the patient which who has a name as a Q2. If we want to know the data from the Q2, so we can just print health data and using the square bracket, yeah. So we give the index as a Q2, so it will give you the data from the Q2 for each year. Each year, he visited the doctor 2 times, right? And the heart rate and the temperature will be like this, right? Okay, the next one is shorted and unshorted indices. Okay, let me minimize our previous code first, so it will not make you confused. Okay, shorted and unsorted indices. Many of the multi-index slicing operations will fail if the index is not sorted. For example, we create a new index here, index equal pd.multi-index dot from product ACP and 1 and 2. So we have two different index here, ACP and 1,2. And so we create a data also here, data equal p.series and p.random 6. Yeah, so we have 6 items inside our data variables, and we give the index to the index variable that we have created before. And we also give the name for our columns, yeah, for our data columns to char and int, char and integer. So because we have 2 different index here, acp as a char and 1,2 as a integer. And if you print the data, yeah, using regular slicing method, yeah, in NumPy or in Python, so it will give you the error message. Why? Because if we use the multi-index, we need to sort, yeah, we need to sort the indices first before we slicing our data. Okay, okay, let me execute this code first. So, okay, this is the data that we have, because the char columns, yeah, the char index, we have not short, yeah, we have not short the index, yeah, because after A it should be B, not C, yeah. And in our example, we have the C after A, so we need to sort it first. Okay, if we print the slicing using regular method in Python, so it will give you the error message, right? So how to solve this problem? We need to sort it first before we slicing our data. Okay, let me execute the code first. Okay, although it is not entirely clear from the error message, this is the result of the multi-index not being sorted. For various reasons, partial slices and other similar operations require the level in the multi-index to be inserted or lexicographical order. Pandas provides a number of convenience routines to perform this type of sorting. For example, we can use the sort index or sort level methods of the data frame. Okay, let's try to use the sort index method. So, because we have the data, yeah, we have the data here, so we need to sort the index first, yeah. Okay, data equal data dot sort underscore index, yeah. Then after that, after we sort the index, then we slice our data. It will give you the output. Yeah, we don't see the error message here because we have already sort the index. Okay, the next one is index setting and also resetting. Another way to rearrange hierarchical data is to turn the index labels into columns. This can be accomplished with the reset underscore index method. So for example, here we create another variable pop underscore flat equal pop.reset underscore index name equal population. Then we will print the pop flat. So it let's see our previous code here, because we back to the pop variable. So this one, yeah, this one is the pop variable. We already create the pop variable, and we want to reset the index of the pop variable. If you use this code, yeah, if you use the reset underscore index method, so it will convert our pop variable to a regular data frame, right? So regular data frame, so it means we have a table with the rows and the columns, yeah. So it will give you the output like this. Okay, let me execute the code first. So this one, yeah, we reset the pop, yeah, we reset the pop variable to a regular data frame. So we create another variable here, pop underscore flat equal pop.reset index name population. So what is name population? So it will represent the third column, right? The third column, because we have not already create the name of our third columns. The third columns will represent the population, right? If we go back to our previous code, yeah, here we have only states and years, right? States and years. We have not already give the columns for our subcolumns, right? So this one name equal population, so it will give the name for our subcolumn. Then after we print our data frame, so it will give you the output like this. And the next one is we can also give the name for the state and also the year, right? So yeah, often when you are working with the data in the real world, the raw input data looks like this, and it's useful to build a multi-index from the columns values. So this can be done with the set index method, yeah, of the data frame, which returns a multiple index data frame. Okay, so it will give you the name for our first and second column. Actually, uh, we have already created the state and year before, right? So if we set the index state and year, so it will uh, convert it back our pop flat, yeah, to a multi-index data frame, right? So it will give you yeah, it's similar with our data frame, but actually this one, because this one is regular data frame and we set the index to the state and the year, so we only print the states one time, yeah. California, New York, and Texas, yeah. So we don't need to print it two times, yeah, because we have already create the index for our first column and the second columns, right? So the state and the year and the population, so it will give you the output like this. Okay, that's all from the hierarchical indexing, yeah. So actually this that's all from the multiple index series. So the next one we will learn about how to combining the data set using the concat and append method. Okay, we will discuss about combining data sets using concat and append method. Some of the most interesting practice of data come from combining different data sources. This operation can involve anything from very straightforward concatenation of two different datasets to more complicated database style joins and merge that correctly handle any overlaps between the datasets. Concatenation of series and data frame objects is very similar to concatenation of NumPy arrays. The method that is used in pandas, yeah, we have a pandas.concat, which has a similar syntax to NumPy concatenate, but contains a number of options. Yeah, we have a similar method, which if you compare with the NumPy concatenate, yeah, pandas concat has a similar function with the NumPy concatenate. It's similar but not same. And also there are some differences between pandas concat and NumPy concatenate. Some of the most interesting practice of data come from combining different data sources. These operations can involve anything from very straightforward concatenation of two different datasets to more complicated database style joins and merge that correctly handle any overlaps between the datasets. Yeah, like I was mentioning before, we can combine two different datasets. Yeah, it can be a series or it can be a data frame. We have more than one data frame or we have more than one series. Then we can combine that two variable to a new variable. So for example, here we have two different variable, ser1 and ser2. Yeah, ser1 equal panda series ABC, and we give the index to 1, 2, and 3. So the item will be A, B, and C for series 1, yeah, ser1. And for ser2, we have a DEF as the items, and 4, 5, and 6 as the index. So we can combine these two variables using concat method in pandas. So we can just call the pt.concat and we give the parameters to ser1 and ser2. Remember, if we use the concat method, inside the concat method, we need to give the square bracket, open and close square bracket. Then inside that square bracket, we put the two variable that we want to combine. So let me execute the code. So this one is share1 and share2. If we use the pt.concat, so it will combine these two variables. Okay. And it also works to concatenate higher dimensional objects such as data frames. Yeah. So previously we used the series, yeah, one-dimensional data, and now we use the data frame or two-dimensional data. So here you can see we have two different data frames, the F1 and the F2. Each of these data frame has some item. Yeah. So the first data frame, the F1 equal pt.data frame, and we keep the two rows and two columns. Yeah. So here we have A columns and B columns, and inside the A columns we have two items, A1 and A2, and also in B columns we have B1 and B2, and we give the index to 1 and 2. And for the second data frame of the F2, we have also same columns. Yeah. So but it has a different items, A3 and A4 for the A columns, and B3 and B4 for the B columns. And we give a different index here. We give the 3 and 4 index for the BF2. So how to combine these two data frames? Yeah, it's similar with we have done before in series dataset or in series variables. So we can also use the pandas.concat, right? So here we can just execute this code, then print the TF1 and print the F2. As you can see here, we have a two-dimensional data, the F1 and the F2. And if you want to combine these two data frames, yeah, you can just call the concat method, pt.concat, and inside this method, yeah, it's similar with we have done before in series. Yeah, so we put the F1 and the F2. So it will automatically combine the F1 and the F2. As you can see here, yeah, it's similar with the concatenation in NumPy array, because if you use the concatenation from the pandas, it will combine by using the columns. Yeah. Sorry, the rows. So the default value of the axis will be 0, not 1, because we combine vertically, not horizontally, right? Yeah, by default, the concatenation, yeah, takes place row wise within the data frame, or the axis equals 0. Yeah, like I was mentioning before, we use the axis equals 0 for the default parameters, because yeah, we combine the rows, not the columns. Yeah, it's similar with the concatenation from the NumPy. Yeah, pt.concat allows specification of an axis along which concatenation will take place. So here, as you can see here, we also be able to use different parameters for the axis. For example, here we give the axis parameters to 1, so it will combine these two data frame. We will combine these two data frame by its columns, not the rows, right? But actually, it has some differences. Yeah, if we compare with the concatenation in NumPy, because if you use the axis equal 1 in pandas.concat, so it will give you the not a number values, right? For the rows 1 and rows 2 in column A and B, and column in rows 3 and 4 in column A and B also. Yeah, one important difference between NP concatenate and pt.concat is that pandas concatenation preserves indices. So it will preserve the indices, even if the result will have duplicate indices. Okay, how to combine vertically and horizontally? Yeah, we will discuss it after this. But if we use the axis equal 1, it will give you the output like this. Okay, so we go to the another example here. Actually there are some difference between the code in the slide and also with my code in Google Colab. Yeah, it's okay, because I think I did some typo in the slide, so let's follow the code from the Google Colab. So we have two different variables, x and y. Yeah, x and y are the data frame variables. So we give the x and y some items here. Yeah, a0 and a1, b0 and b1 for the column a and b, and also we create another variable y. Yeah, as you can see here, we have two different data frames, and we want to copy the index from x data frame to y data frame. So if you do like this, so the index in y data frame will be the same with the index in x data frame. Okay, let's execute this code. Then execute the next code. As you can see here, we combine the x and y data frame. Then it will give you the output like this. Yeah, because the y index is similar. Yeah, it's the same with the x data frame index. Yeah, so it will give you a 0101 index. Yeah, after we combine these two data frames. Yeah, notice the repeated indices in the result. Yeah, while this is valid within data frames, the outcome is often undesirable. PD.concat gives us a few ways to handle it. Okay, let's go to the next slide. Yeah, if you like to simply verify that the indices in the result of PD.concat do not overlap, yeah, you can specify the verify underscore integrity flag. With this set to true, the concatenation will raise an exception if there are duplicate indices. Here is an example where, for clarity will catch and print the error message. So, okay, if the x and y have same index, yeah, have the same index, yeah, so it will give us the error message because we want to avoid overlap, because we can say the overlap if the two data frame has a similar index. Okay, so to check if the x and y has a different index, so we can use this code. Yeah, we can use the try and catch. Yeah, sorry, in Python we can say that try in except. Yeah, so inside our try, for example here we declare a new variable z equal pd.concat x comma y, and we give a verify integrity equal true. So it means if the x and y have a same index, it will give you the error message. Yeah, it's just to verify that the two data frames that we want to combine have a different index. Yeah, because we already copy the index from the x data frame to y data frame, so it will give us the error message if we execute this code. Okay, but if we want to ignore the overlap, yeah, so for, by default verify integrity sorry we discussed about the ignore index. Yeah, let me go to the next slide. So sometimes the index itself does not matter, and you would prefer it to simply be ignored. You can specify this option using the ignore underscore index flags. And with this set to true, the concatenation will create a new integer index for the resulting series. Okay, for example, here, if we want to ignore about the overlap, yeah, we can just use the ignore underscore index equal true. So it will give the y data frame new index, yeah, not 0, 1, but 2 and 3. If we use the we ignore the index, yeah, so it will give us a new index for the y data frame. Another alternative is to use the keys option to specify a label for the data source. The result will be a hierarchically indexed series containing the data. Yeah, for example, here we have a X and Y data frame. Yeah, like we were discussing before, but we can also give another case here. So although X and Y have a same index, but we give the additional keys X and Y. So here we can also add the keys parameter. So it will give us X and Y keys. Okay. The next one we will discuss about the concatenation with joins. In the simple examples we just looked at, we were mainly concatenating data frames with shared column names. In practice, data from different sources might have different sets of column names, and digital concat offers several options in this case. In the example on slide 22, yeah, by default, the entries for which no data is available are filled with name, not a number values. Yeah. So we refer to this code, yeah. In the example on slide 22, by default, the entries for which no data is available are filled with not a number values. To change this, we can specify one of several options for the join parameter of the concatenate functions. By default, the join is a union of the input columns. Yeah, by default, the join parameters will be altered, but we can change this to an intersection of the columns using join equal. Okay, we will discuss about this after on the next slide. Okay, for example, here we have df1 and df2. Yeah, df1 and df2. So it refers to our previous code here. Yeah, so we have df1 and df2. Yeah, and they are the data frame variables with a different index. Yeah. Then we combine the df1 and df2 with the join equal inner parameters. Okay, let's execute this code. Yeah, it differs if we use join equal outer. So let me add another code here. So we don't need to add this one. So we don't need to give the join parameter because the default value of the join parameters will be altered. Wait. Okay, it will give us the same output, right? Yeah, because A1, sorry, TF1 and TF2 has same dimension, yeah, same dimension and also same index. Okay, because the TF1 and TF2 has same columns, yeah, same columns. It means X and TF1 has A and B columns, and also TF2 has A and B columns. They have a same column, but we can go to another example here. We have df5 and df6. Yeah, we have df5 and df6 here. df5 and df6 have different columns. As you can see here, A, B, and C are the columns for df5, and B, C, and D are the f6 columns. The f5 and the f6 have different columns. What about if we combine these two data frames? So as you can see here, if we execute this code, it will give us the not a number values, yeah, on the columns, yeah, for the TF5, yeah, because TF5 doesn't have the columns, and it also happened in the F6 because the F6 has no A columns, yeah, so it will give the values in A columns, not a number, right? Okay, let's refer to our previous code. Okay, this one also give us the not a number values, the F1 and the F2, right? Because we combine the F1 and the F2 with the axis equal 1, not axis equal 0. So it will copy, yeah, it will uh, uh, copy the same columns. It will give multiple columns for A and B, right? Okay. Okay. The next one is append method because direct array concatenation is so common. Series and data frame object have an append method that can accomplish the same thing in favor instruction. For example, rather than calling pd.concat, you can simply call the f1 to append the f2. Yeah, it's similar. It has the similar function with the concat in pandas. We can also use the append, yeah, but actually the append we need to call the first data frame, then we can just add the append method, and inside the append method we can just give the second data frame. Okay, how to use the append method, yeah. So here, as you can see here, we have the f1 and the f2, and we can add the tf2 to the tf1 using the append method. So here, as you can see here, it's similar with the pd.concat with axis equal 0, right? So it will combine the rows from the tf1 and tf2. Keep in mind that unlike the append methods of Python list, the append method in pandas does not modify the original object. Instead, it creates a new object with the combined data. So actually, if after we execute this code, yeah, so the f1 will still has this item, it will not add a new item in the f1 because actually the append methods in pandas it's different with the append method in Python list because it creates a new object with the combined data, so it will not modify the f1. Yeah, so actually after we execute this code, we just print the tf1. It will still give us the same item with our previous code. It's not very efficient method because it involves creation of a new index and data buffer. Thus, if you plan to multiple append operation, it is generally better to build a list of data frames and pass them all at once to the concat function. Okay, that's all from the append and also concat method.
Okay, and the next one we will discuss about the combining datasets using merge and join method. If you have ever worked with databases, you should be familiar with this type of data interaction. The main interface for this is the pd.merge functions. The pd.merge function implements a number of types of joins, such as the one-to-one, many-to-one, and also many-to-many joins. All three types of joins are accessed via an identical call to the pd.merge interface, and the type of join performed depends on the form of the input data. Yeah, it's similar with the relation between one table to another table. If we use the database, yeah, we can create a relation between two tables. Yeah, pd.merge function is similar with the a relationship between two tables in a database. Perhaps the simplest type of merge expression is the one-to-one join, which is in many ways very similar to the column-wise concatenation. So here we have two data frames, the F1 and the F2. And for the TF1, we have two keys here, employee and group. Yeah, we have two index here, employee and group as a columns. And also we also have TF2. It's also a data frame. It also have employee and employee columns and hire date columns. Yeah. And if we print these two data frame, we will get the output like this. This one is for the F1 and this one is for the F2. And if you want to join, if you want to merge these two data frame, yeah, we can just use the pd.merge function. As you can see here, this is the output if we combine or merge these two data frame. As you can see here, because these two data frame has same columns, which is employee columns. So here you can see, for example, Bob, yeah, Bob, the employee with the name of Bob will have a group accounting, and the hire date, yeah, it get the hire date data from the TF2 data frame. Yeah, because as you can see here, Bob has a hire date in 2008. So we have a 2008 in hire date after we combine these two data frame. Okay, let's execute this code. Yeah, so here we have the F1 and the F2. After we merge the TF1 and the F2, we will have the output like this. Why we call it as a one-to-one joins? Because here we only have Bob. Yeah, we only have one Bob in the F1, and we also only have one Bob in the F2. Because there are no duplicate data in the F1 and in the F2, because yeah, we only have one data from the F1 and we also have one data from the F2. As you can see here, Bob, Jack, Lisa, and Sue, yeah, all of these employee only have one rows, yeah, one data in the F1 and the F2. So we can call it as a one-to-one joins because there are two duplicate data on the F1 and the F2. There are no more than one duplicate data in the F1 and the F2. Okay, and the pd.merge function recognizes that each data frame has an employee columns and automatically joins using the column as a key. And the result of the merge is a new data frame that combines the information from the two inputs. Yeah, we don't need to worry about which of the columns that we want to merge. Yeah, because if we use the pd.merge function, it will recognize automatically which columns, yeah, which columns that is on the F1 and the F2 with has a similar name. Yeah, because employee, yeah, the F1 has the employee columns and the F2 also have the employee columns. So the pd.merge function will recognize it automatically. And the result of the merge is a new data frame that combines the information from the two inputs. Notice that the order of entries in each column is not necessarily maintained. In this case, the order of the employee column differs between the F1 and the F2. And the pd.merge function correctly accounts for this. So we don't need to worry about the order of the data. Yeah. So as you can see here, if we see the output here, the order will have the similar order in the TF3. Yeah, will have the similar order with the TF1 for the employee columns. Additionally, keep in mind that the merge in general discards the index, except in the special case of merge by index. Okay, we go to the next slide. Yeah, so the next one is many-to-one joins. Yeah, many-to-one joins are joins in which one of the two key columns contains duplicate entries. For the many-to-one case, the resulting data frame will preserve those duplicate entries as appropriate. Okay, let's see the example in many-to-one joins. Yeah, here we have DF4. DF4 has group columns and also supervisor columns. Yeah, if we print the DF4, it will be like this. Yeah, group and supervisor. And we want to combine the DF4 with the DF3. So we already have the DF3, yeah, in the previous code. Yeah, so these are the DF3 with this one is the DF3. Yeah, so we will join the DF3 with the DF4. So here you can see that the in DF4, yeah, in DF3, yeah, in DF3 we have a duplicate entries in group columns, which are engineering entries. Yeah, we have a 2 engineering entries in DF3, but in DF4 we only have 1 engineering data. So we don't have a duplicate entries in DF4, but we have a duplicate entries in DF3. That's why we call it as a many-to-one joins, because one of the data frame has a 2 or more duplicate entries. Yeah, as you can see here, if we merge the DF3 and DF4, it will be like this. Yeah, so we have a duplicate entries for the engineering because DF3 and DF4 has a similar columns. Yeah, has the same column in group columns. So as you can see here, the engineering, yeah, the engineering data entries in Chick and Lisa, yeah, it will be like this, right? So yeah, it will be like this. Yeah, that's why we call it as a many-to-one joins. So yeah, engineering in 2012 and engineering in 2004, and it will combine. Yeah, it will merge with the engineering in DF4, yeah, which is the engineering has a Q2 as a supervisor, right? So engineering 2012, engineering 2004, and the supervisor will be Q2 and Q2. Yeah, so we call it as a many-to-one joins. Many-to-many joins are a bit confusing conceptually. Yeah. Now we discuss about the many-to-many joins. Yeah, many-to-many joins are a bit confusing conceptually, but are nevertheless well defined. Yeah, if the key columns in both the left and right array or left and right data frame contains duplicates, yeah, then the result is a many-to-many merge. This will be perhaps more clear with a concrete example. Yeah, we will see the example of the many-to-many joins. Consider the following, where we have a data frame showing 1 or more skills associated with a particular group. Yeah, by performing a many-to-many join, we can recover the skills associated with any individual person. Okay, let's see the example. We have another data frame here, the F5. Yeah, so actually the F5 has a group and group and skills columns. Yeah, and we want to merge the DF5 with DF1. As you can see here, we have DF1 and we have a duplicate entries in DF1, yeah, which is a group. Yeah, because in the group columns we have 2 engineering data entries in DF1, and if we see in DF5 we only have we also have the duplicate entries, yeah, which is accounting and engineering in the group columns. We have a 2 accounting data entries, and we also have a 2 engineering data entries in the F5. So we can call it as many-to-many joins because the F1 and the F5, yeah, have a duplicate data entries in group columns. So if we combine the DF1 and the F5, yeah, if we merge the F1 and the F5, and we will have a new data frame like this. Yeah, so accounting and accounting, engineering, yeah, because you see here because we have 2 accounting, yeah, in the F5. So Bob, yeah, Bob in the new data frame we will also have two accounting data entries in the group columns, yeah, which is a math and spreadsheets, yeah, for the skills. And what about the check? Yeah, because the check is check has an engineering, yeah, group, yeah. So as you can see here, we also have two engineering data entries in the F5. So actually, check will also have two engineering data entries, yeah. And for the skills, we will have a coding and Linux. And it also happened in the Lisa, yeah, because Lisa also has a engineering data entries, yeah. So actually, we will duplicate the Lisa employee, yeah, 2 times because it has a two engineering data entries, and so on and so on, right? So we can call it as a many-to-many joins, yeah. Okay, let's execute the code, yeah. So this one is, yeah, many-to-one joins, yeah. We have not execute this code, yeah. Yeah, let me execute the code for the many-to-one joins. And we also have here many-to-one joins. Okay. Okay, this is the F1 and the F5. If we merge the DF1 with the DF5, it will be like this. Yeah, it's like duplicating the employee, the data for the employee, right? Bob 2 times, check 2 times, yeah, Lisa 2 times, and Sue 2 times. Okay, the next one is the specification of the merge key. We've already seen the default behavior of the pd.merge function. It looks for one or more matching columns name between the two inputs and use this as the key. However, often the columns name will not match so nicely, and pd.merge provides a variety of options for handling this. Most simply, you can explicitly specify the name of the key column using the on keyword, which takes a column name or a list of column names. Yeah. Maybe in the real case, yeah, we have a different column names, yeah, but it represents the same data. So we can use the on keyword in the pd.merge parameters. So for example, here we want to combine the df1 and df2, yeah, on employee columns, yeah. So let's see the df1 and df2. Yeah, because the df1 and df2 has a similar name of the employee columns, yeah. So we can just combine it to the employee. I'm sorry, I mean, if we have two data frame that has two same column names, yeah. For example, yeah, we have two different data frame which has two more than one same columns, yeah. So we can just use the on keyword, yeah, on the parameters. So I mean, if we have a two or more same column names, yeah, in our data frame that we want to merge, so to avoid the confusing, yeah, about the which one of the column that we want to merge, yeah, so we can just use the on keyword, yeah. And that option works only if both the left and right data frames have the specified column names, yeah. Yeah, because in this example, actually the F1 and the F2 only have one column name, yeah, one column same column name. So actually, if we don't use the on keyword, yeah, it's not a problem because the F1 and the F2 has already same name, same column names, yeah. So we don't need to use the on keyword. It's okay. But actually, if let's assume that the F1 and the F2 has a two same column names, yeah. So we need to use the on keyword here. Okay. So yeah, let's just execute this code. It will give the output like this. Yeah, at times you may wish to merge two datasets with different column names. Yeah, for example, we may have a dataset in which the employee name is labeled as name rather than employee. Yeah. That's what I was mentioning before. Yeah. In the real case, maybe we will have two different column names that represent the same data. So for example, the first data frame has a name column and the second data frame has the employee columns. Yeah. In this case, we can use left on and right on keywords to specify the two column names. Yeah. So for example, here we have a DF3 which has the name and salary columns. Yeah. Then we want to merge the DF3 with the DF1. So actually in DF1, we have employee columns. Yeah, DF1 has the employee columns, not the name columns. And we want to combine the employee columns in DF1 and name columns in DF3. So we can use this code. Yeah, pd.merge DF1, DF3 left on employee. So it represents the employee, the employee columns on DF1, right? And the right on parameters will be name because in the F3 has the name columns. Yeah. So if we combine or merge the DF1 and the F3 with this code, it will give the output like this. Yeah. So it means we will have the new data frame, yeah, from the F1 and the F3 that's already combined, yeah, in the employee columns. Yeah. Okay, so let's execute the code. Yeah, so we have the F1 and the F3. If we merge the DF1 and the F3 with the left on and right on parameters, yeah, so it will give the output like this. So yeah, wait, name with I think I'm not already execute the DF3 code. Yeah, so this one is, yeah, okay. Okay, so the DF3, yeah, the DF3 has the name columns and it will assume as a employee columns. Yeah, so it will be like this, the output for combining the two data frame with has different column names that represent the same data. Okay, the next one is the result has a redundant column that we can drop if desired, for example, by using the drop method of data frames. Yeah. For example, if we want to drop the name, because if we use this code, yeah, with the left on and right on parameters, actually we still have the name columns, right? But if we want to drop this column, yeah, we can just add some code here. Yeah, we can just use the dot drop name axis equal 1. So it means we will drop name columns. Yeah, so here we can just execute this code, so it will drop the name columns. Yeah, sometimes rather than merging on a column, you will instead like to merge on an index. Yeah, for example, our data might look like this. We have the F1A and we also have the F2A. Yeah? It has a same index, yeah, which is employee index. Yeah, the F1A equal the F1.set index employee, and the F2A equal the F2.set index employee. So actually the F1A and the F2A will represent the F1 and the F2 with the employee as the index. Yeah. So, okay, let's execute the code first. If you execute the next code, it will be like this. Yeah, so we have the F1A and we also have the F2A, which has the employee columns. Yeah. Okay, we can use the index as the key for merging by specifying the left index and or right index flags in pd.merge. So for example, here we have another code, pd.merge the F1A and the F2A, left index true and right index true. It will give the output like this. Okay, let's execute the code. Okay, so it will give the output like this. And the next one is the specifying set arithmetic for joins. In all the preceding examples, we have glossed over one important consideration in performing a join, the type of set arithmetic used in the join. This comes up when a value appears in one key column but not the others. So what if we have the case that in one DF6, yeah, so we have two data frame, DF6 and DF4. So actually DF6 has name and foot columns, yeah. And in name columns, the F6 has Peter, Paul, and Mary. And in the foot columns, the F6 has fish, beans, and bread. But if we compare with the F7 also has similar columns with the F6 in the name columns. Yeah. So let's see in the F7. So this one is the F7. So let me execute the code first. Yeah. So we have the F6 and the F7. So here you can see the F6 and the F7 has similar column, which is name columns. But actually, the data entries in the name columns in the F6 has different data entries with the name in the F7 data entries, which is we have Peter, Paul, and Mary in the F6, and we also have Mary and Joseph in the F7. So actually, only have the F6 and the F7 only have one similar data entries, which is Mary, right? Peter and Paul, yeah, is not in the F7, and Joseph is not in the F6. Here we have merged two datasets that have only a single name entry in common, Mary. So if we combine or merge the F6 and the F7, it will give us the output like this, because it will merge only the rows in the F6 and the F7 with which has similar data entries, which is Mary, right? So it will be it will give us the output like this. By default, yeah, the result contains the intersection of the two sets of inputs. This is what is known as inner join. Yeah. So if we execute the code, this code, so it will give us the inner join method. Yeah. So actually, it will only join the data that has the same data entries in the F6 and the F4, the F6 and the F7. We can specify this explicitly using the how keyword, which defaults to inner. So by default, we will set the how parameters to inner. If we don't use the how parameters, yeah, it will automatically set to inner. But what happens if we change the how parameters to another values? For example, here we also have another values in how parameter, which are outer, left, and right. An outer join returns a join over the union of the input columns and fills in all missing values with a not a number. So actually, if we execute the code and this code with how parameters set to outer, so it will give us the output like this. So actually, it will join the DF6 and the F7 with the outer join, and it will give us the not a number for string columns, yeah, in Peter and Paul, yeah, because actually Peter and Paul, yeah, in DF6, yeah, is not in the F7 because there is no Peter and Paul in the F7. So that's why we set the it will set the string for the Peter and Paul to a not a number. And it also happened, yeah, in Joseph data, yeah, because Joseph is not in the F6, yeah, so it will give the output, it will give the data not a number in foot columns. Okay, what about if we set to left? Yeah, so actually if we set the how to left, so it will remove the Joseph, yeah, because foot and string, let's assume foot is in left column, yeah, and string in the right column. So if we set the left, yeah, so it will remove the data which has not a number in foot columns. And that's also happen if we use right value for the how parameters. So it will remove the data which has not a number in string columns. Yeah, that's why we only have Mary and Joseph here. And the left join and right join return join over the left entries and right entries respectively. Yeah, so that's what I explaining before. Yeah, so it will give us the output like this, and the output rows now correspond the entries in the left input using how equal right works in a similar manner. Yeah, and the next one is overlapping column names. Yeah, finally you may end up in a case where you two input data frames have conflicting column names. Yeah, consider this example. So actually we have a df8 and df9 which has the same columns, name and rank. Df8 has name and rank columns, and df9 also has name and rank column. But actually there are some conflict, yeah, inside the rank columns, yeah, because the df8, yeah, has 1, 2, 3, and 4 for the rank, and the f9 has 3, 1, 4, and 2. So actually they have the same column names, which are name and rank, but actually the data entries inside the rank columns, it's different between the f8 and the f9. So we can call it as overlapping column names. So when we merge these two data frames, the f8 and the f9 on name columns, yeah, it will give us the output like this. So it will give us two different columns, yeah, rank X and rank Y. So rank X will represent the rank from the df8, and rank Y will represent the rank from the df9. Yeah, so let's execute the code. So this one is the code, yeah. So it will print the df8 and df9, which has the similar column names. And if we merge the df8 and df9, it will give the output like this on the name, yeah, on name columns, yeah. So we merge df8 and df9 on name columns, yeah. So we from previous slide, because the output would have two conflicting column names, the merge function automatically appends a suffix underscore x, yeah, or underscore y to make the output columns unique. If these defaults are inappropriate, or maybe you want to change the suffix name of the rank, yeah, so it is possible to specify a custom suffix using the suffixes keyword. So this is the how we use the suffixes keyword, yeah. So we give another parameter series suffixes, yeah, equal underscore l and underscore r. So maybe we want to give the keyword to left and right, yeah. So it will give us the output like this. Okay, let's execute the code. So it will give us rank underscore left, yeah, and rank underscore r. Okay, that's all the course in week 7. So we will discuss about your problem. Yeah, if you have any problem when you implement the code in the slide, so we'll discuss it on live Zoom class in week 7. Okay, thank you.